Believe it or not, when I boiled the pepperoni pizza as my leftovers, is bussin'. So that was pretty cool. All right, welcome back, everybody. It is Wednesday. We are on the downhill side of the week since it's after lunch. There's a TikTok trend going on where something about show me some money or something. I'm not a TikToker. I'm a content creator. I don't browse it. That's a lie, just for the record. But I am the sophomore class advisor. I just walked into my meeting like, hey, Mr. Holloway, we do a TikTok with us? Yes, I'm down. I don't care. And they got me good. All right. So you might see that in just like total defeated, sad Holloway on TikTok later tonight. But, all right. So we are talking about the scientific method. We will find some sort of question. We're going to ask it, right? We will do our due diligence and work to make sure that we are using reputable sources to get research to see what has been answered and addressed about the question. We will then form our own educated hypothesis, which may or may not need to wait for technology to catch up to be able to test it. Now, in this test, remember we can do it via experiment or observations. After we work through the whole scientific method, we're going to look a little bit more closely at when conducting experiments, what are the things that we must consider. Let's say we've done our test, we have all this data. We now get to the point where we will analyze our results. When analyzing results, we have to make sure that we're not just like dumping terabytes of data somewhere for somebody to try to parse through, right? We need to actually go through and organize in a readable fashion is a little comment that I would make here. And I might have worded something along those lines. Organized in a meaningful way is an important part of that data. Now, without a doubt, every single one of you's favorite class is math, probably algebra. And in that specifically, you guys love graphing, I think. Right? Word problems and graphing, that's everybody's favorite thing in math. Excellent. So, obviously I know that's not the case, right? But when you organize this data in a meaningful way, what we will be looking for, especially from the physics standpoint, is like it or not, we are going to get practice in this class as well as Algebra 1 in using graphs and making graphs from a set of data. Now, it's not going to be as hardcore as like, let's do all of our y equals mx plus b and all that stuff, but the ideas that you learn in algebra will immediately be applied in here as well. So, if you struggle with it, is that okay?
Yes.
For sure. You think I might be able to help with the math stuff? Absolutely. I have much more experience teaching math than science. Love them both, but math is like my whole focus area when I was younger. Okay, so we've gone through, we've organized our data, maybe we've made some sweet graphs or something. What comes next?
Public.
We hopefully will have some sort of work which can be published. So we're going to sneak in two different sections here, or two little ideas here. When we publish, it is just us putting out our data out into the world, right? Because in the world of science, what I do in my lab and what you do in your lab, assuming we run the same experiment, they should produce the same results. And you ought to be able to verify or disprove what I have claimed I've done. So, after analyzing these results, we will publish. Now, there's a couple different pieces here that could change around. Publish, and I publish for a specific reason. I need people to verify that I'm done everything correctly. Who do I trust to check my work? Say it again? It could be another teacher, absolutely. Assuming that we are experts in our field, whatever field it is that we're working, there are probably other experts in the same field. It is our goal to publish and submit our work for peer review. Now, when you hear the word peer, your mind may go directly to saying, oh yeah, a peer is just my buddies. Now, if I wrote a big paper, like hypothetically, I'm working for an oil company, and I write a big paper talking about how, yeah, oil is actually not anything that's polluting our environment. If I then have a buddy that works for the same oil company and I say, hey, check my work, might they come to the same conclusion with the same bias that I brought in? So if I said oil is great for the environment and you work with me, you check this, and he says oil is great for the environment, have I done a good job as a scientist in publishing my ideas and the truth? No, we want people who may work with us, but we also want people who don't work with us, somebody who might push back against our ideas, because we want to be wrong. Because if I come to a conclusion and somebody else finds it wrong, we now have room to keep growing that idea and developing it. So we'll publish and peer review, and it'll be submitted. Now, in this process, there's only one of two things that can happen. At the very beginning, once we've come up with a problem or a question that we're asking, we've done all the work, we've tried to prove it, is it possible that what I thought was going to happen did indeed happen? Yeah. So maybe it's happened, and within this, we just have a small little offshoot. So maybe as we publish and we're getting peer reviewed, what we find is that our hypothesis is confirmed, which that's awesome. If that's what happens, sweet. It means we've done a good job. Now, there's another option that certainly could be waiting there. Maybe we go through all this work, we publish, and we peer review, and whether our published results were in support of or not our hypothesis, somebody came back and said, wait a second, this doesn't quite work. And we rerun this data and we run the test, and all of a sudden we decided we were wrong. Does that mean we have failed in science? No. So hypothetically, let's just go ahead and knock off this other branch. If our hypothesis is wrong, hypothesis is wrong, does that mean that we're bad scientists? No, absolutely not. We're going to be wrong. I'm going to be wrong from time to time in here. Call me out on it. You'll be wrong. I will call you out on it. Hopefully your peers do as well. In the case that we're wrong, what happens? We retry. So does that mean just, man, my question just was not good, it sucked, I'm not going to ask that question anymore? Where do we retry? We reform our hypothesis. I'm going to sneak through here. We reform hypothesis and repeat the process. Now, this could take multiple iterations, meaning that maybe we try it once and we have to reform our hypothesis. We have a new one, we work all the way back through it, and all of a sudden we're wrong again. We retry, we're wrong again. This cycle is what's going to eventually lead to a better understanding of our natural world. Like, that's the goal. Okay. The scientific method, pretty sure y'all have seen it before. Are there parts of this that you would like us to discuss at greater length? Or are we okay with saying where we are now is fine and we'll keep revisiting it because we will be using the scientific process this year? Thumbs up says, yep, I'm good. We can move on past just talking about the process. Thumbs down says, what's a method? And we need to restart everything. You can also be somewhere in between, just so you know. Like, there's very few times. Okay. Now, in here, instead of shoving it into this nice flow chart and making this look clunkier, which honestly it kind of looks clunky right now, we should probably talk a bit more specifically about the data that we collect via our test and before we analyze our results. So we're going to spend just a moment as a little extension on the scientific method. We need to talk about our types of data. Now, if you were to pursue a degree in a field where you're going to be really research-based, so like you're going to be working at a university or a college or a research institute, there are literal classes, like full year-long or semester-long classes that people do to talk and go through the types of data. It can get really, really boring. From my point of view, some people are really into it, but I think it gets really dry really fast, and it's not always the most fun discussion to have. For our purposes, we get to simplify that down a ton. Oftentimes, we will work with numbers and mathematic relationships, right? Like, we're going to do math in here. This is a physics and chemistry course. As we go through here, we need to make sure that we can all agree on some words that you've probably already heard Mr. Russell or Ms. Jarvis say before. First off, we're going to sneak in a few vocab here. When we look at data, we will regularly have what is known as a variable. Have you guys heard the word variable already this year with Mr. Russell? Yes. What's a variable?
Something that changes.
I like that. I heard something that changes. Now, instead of the word change, there's another word we might be able to use.
Unknown.
So you could call it an unknown, absolutely. Instead of saying change, could we say varies? Because varies and change mean the same thing, and all of a sudden, why we call it a variable, because it varies, makes so much more sense. So, in here, we're just gonna make sure that we understand that one, it's going to represent a quantity or a number. We'll just simply say, hey, anytime we have a variable, it's simply going to be a quantity that changes, or that can change. Now, in the world of algebra, you typically are going to be assigning the letter x to your variable. That's like the most kind of entry point that you'll use. And oftentimes we do treat it as an unknown. You guys will probably begin by solving equations, is probably what you're doing right now. Single step equations where you have 2x equals 5, and now you're solving that just for some unknown value of x. Later this year, you'll start to see that that value of x, or maybe you've already seen it. Have you guys graphed like f of x and y equals mx plus b stuff ever? Yeah. Okay, so you get to actually pick the value of x and see how it changes the shape of whatever you're dealing with. It changes as we go through. We might get to know it at certain times, sometimes we won't. Beyond just variables, there are two types of variables, and we're only thinking in nice flatland graphs. So on the coordinate plane, just that regular grid that you work with, you have two types and two letters that you normally use. One's x, and what's the other one?
Y.
Okay, which one's this direction? And this one is? Y. Okay, instead of calling them just x and y, which is fine, those are the norms that we will use. More commonly though, especially if we're not just dealing with unknown stuff, they might have actual labels. So we need to make sure that we are comfortable with distinguishing between what is known as the independent variable, independent, and I'm going to use, instead of writing the word variable again, on your fancy calculators that you guys get, VAR is the shorthand that they use for variable. I suggest we just use that when we're writing. Max, do you need a sheet of paper? Man, so never hesitate to interrupt me. I will get you a printout from yesterday's stuff as well. Do you want graph paper or blank paper?
That was.
Okay. Here you are. Sorry about that. I should have asked a couple minutes ago. Okay, we have an independent variable. Have you guys heard this phrase before?
Yeah.
Do you remember what it is?
I'm pretty sure it's this thing that doesn't change.
Okay, so as we're looking at this, when we look at the independent variable, we're going to say that this is the one that has changed during the experiment. So if you think of math terms, which I'll try to avoid it, I don't remember anybody like exclaiming yesterday that they loved math yet. We'll get there. Changed during experiment is our independent variable. So when you guys think back to graphing anything last year with Miss Jarvis, do you pick an X or do you pick a Y to plug in? You pick an X, right? You're changing the value of X, and then you're seeing how changing that value of X changes what other number?
The Y.
The Y value. So we have our independent variable, the thing that we change, and I can scroll up. Is that too low? Is that better? Yeah. Okay. Okay, if we have an independent variable, the thing that gets changed, what's the other option? The dependent variable. Now, the dependent, and again, caps just means that I am giving vocab stuff. The dependent variable isn't the one that we change initially. Instead, to make this as nice as possible, we'll say that this one is the one that's impacted by independent. Impacted by, and we'll be specific, changes in the independent variable. Now, I'm going to often catch myself starting to talk before people are done writing, so I'm just going to chill out for a second so I'm not like way ahead of everybody. Independent is the one that we change. The dependent is the one that, based on whatever we change, influences some other number or quantity. Okay. Throughout the day, and here in Unalaska it happens less than maybe other places in the world. If I check the temperature in the morning and then I check the temperature like right now, will it normally change at least a little bit? Okay, let's pretend it's a nice summer day. What normally happens with the temperature? It rises, right? Okay, so if we were to graph that data, one of them winds up being independent, something that changes, and then changes in that variable impact the other. If we were to try to collect a bunch of data on the temperature at, let's say, 10 different times throughout the day, and we started early in the morning and we kept it and watched as the temperature rose throughout the day, which one of those would you consider independent? Before you just shout out the answer, think about it for a moment. If we were doing time and temperature, which one of those would you assign to be the independent variable and why? I'm going to give you a second. I want you to chat quietly either at your individual table or turn around and chat with a larger group. If we're plotting, and I'll write it down in case people just don't like just words, if I wanted to graph temperature or temp and time on a graph, one of those ought to be the independent variable, one of them should be dependent. I'm going to give you about 45 seconds or so. Talk with your neighbors, see if you can convince them of your point of view. Now, gut feeling, which one's independent, time or temp?
Time.
Why?
Because over time the temperature will change.
I would agree with that. Now, that can like mean nothing to somebody though, like because somebody could equally say, well, wait a second. Oh, as temperature changes, the time is changing too, and one could argue it the opposite way. And when I think about these, I'm going to be honest. Sometimes it can be either. Normally, time will be our independent variable. Okay, if you need to phrase it, oftentimes you can get a nice hint towards the answer. Does the time of day impact the temperature?
No.
Like if I said compare on average, is noon warmer or colder than 6 a.m.? Is there an, like it's normally warmer, right? Like time changes and the temperature changes according to time. Now, are there the weird cases where maybe temperature falls throughout the day? It can happen, but if I word that question differently, it's going to feel wonky and just clunky as you try to think about it. Changes in temperature dictate changes in time. No, that just doesn't even fit right, I don't think. If we ever struggle with it, I'll make sure to help. I'm never going to like throw you like crazy curveballs. Time, usually the what? Independent. Whether it's time versus distance or time versus speed, doesn't matter. Normally, time is your independent variable. Now, within this data, when we run experiments, we oftentimes need to try to limit ourselves to how much stuff we're trying to like change at a given time. If I have 5 different values that I count as independent and I change all of them to see how one other thing changes, I'm never going to know which of those 5 led to that direct change. Okay, we have to be careful to make sure that we're getting data that's adjusted for certain changes. With that, other types of variables that we might see. If something is not dynamic, that means dynamic means to change, something is unchanging. You could call it a control. That's what we're going to call it here in a second. Love it. But what's just like numbers are not changing. 5 is 5 is 5 is 5. It doesn't ever change, right? We want to make sure that we're aware that sometimes we will get constants. And if we have a variable that remains constant, what's the easiest way that we can define that?
Doesn't change.
I like that. I would say unchanging or doesn't change. Honestly, you might just be able to say constant because we all, I think, know what the word constant means. But having an alternative is always nice. So I'm going to say unchanging, where you could write doesn't change, stays the same. There's a bunch of different ways that you could word the exact same statement. And then finally, this last one, remind me that other word that you said that I haven't written yet. The control. Okay, when we have a control in an experiment, what we look for is oftentimes it will be some sort of constant. Not always, but it will often be. What we need to make sure is that this is a standard for which we know the results or how these experiments change it. So we're going to make that nicer. A standard which results are compared against. So I'll give you guys a second to get that down, and then my mind always goes directly to the field of medicine when I think about a control within an experiment. If I have a new pharmaceutical drug of whatever case, let's pretend it gives what, like let's say it doubles your brain power, hypothetically. If I want to know if it really does what I claim it does, can I just give everybody a test of some sort and then give everybody this medication and then use that to see if it really changed it? No, because there's this crazy thing that happens. You guys heard of the placebo effect?
Yes.
What is it?
It's where like you think, it's where like if you're, it's like if, I don't know how to explain it. It's like if someone tells you like this will give you like power, and like okay, like you'll it's placebo. It's like your brain will tell you like yeah.
You guys have seen Space Jam?
Yeah.
No.
Which one?
Which one?
Either, I assume.
Yeah.
You know the water bottle that Bugs has?
Yeah.
Does that happen in the second one? They have the.
What is the first one?
It happens in the first one. I don't know if it happens in the second one. I didn't watch the LeBron one. Anyway, Bugs told everybody the water is gonna man, this is gonna make you the best basketball player, and they drank it, and all of a sudden, boom, they're the best basketball players. And your example was a water bottle, so that works perfectly. It was just regular water, but they thought it was gonna affect them, so it did, right? Now, crazy thing about the placebo effect is, if I tell you that this is a placebo, this won't really do it, but I think it will. Do you think it still works?
No. You think so?
Placebo? Oh, I know so. Placebo still works even when people know that it's a placebo, which is mind-blowing to think that your brain, even knowing the truth, can still be convinced otherwise. It's strange. Now, when you do this with medicine, you actually have to do double-blind control studies. So even the people who are giving away the medicine, they don't know if they're giving a placebo or not, because small changes in body language wind up impacting the outcome of that study. Okay, we always want to have some standard with which we can compare our results with. Okay, we have been going for like a good 25 or so minutes. We are gonna do our whine about it Wednesday real quick. But we're gonna continue on, and we're gonna finish our first section over the next couple minutes. Now, in science, there are times when we hear specific things, and there's a few that wind up controversial, but I'm sure you've heard both of them. I don't want these to each be their own sections, but they don't really fit within the other, so as we look at this, we're just gonna put it right here, and meanings in science is what we'll call this. Meaning in science. Are there any, did somebody question? Okie dokie. Okay, can anybody think of any topic in all of science that's kind of controversial? Is it are aliens controversial?
Atmosphere.
Fair believers and non-believers.
Flat Earth. Flat
Okay, in real science. If somebody believes in flat Earth, like I just planted that tree, I'm just gonna let it keep growing, cast shade as far as it can. Not what I was expecting, but that's a fun answer. Real quick, aliens, yes or no in the universe?
No.
Yes.
Let me
Okay. Fair
So
enough.
what do you think?
All right. Oh yeah. Okay. Any others that are controversial that you might see in the news? They talked about it. It's presidential election season starting up. They're gonna be going crazy about a couple controversial science ideas. Maybe a little bit about nuclear weapons, but if you're not part of NATO or have them already, there's not a whole lot that's going to happen because we're going to stop it. Other ideas? Maybe not. Are you guys politically active? I don't know many 14 and 15-year-olds that are. Okay, I'm just going to go right out on it. Theories that exist that are controversial. Okay, so we're still in cryptid land, but that's all right. I'm just going to throw it out there. The theory of evolution is kind of controversial, depending on who you ask. Ideas around climate change are the other big controversial one that we're going to start hearing more and more about in the coming months if you watch the news. Now, we need to make sure that when we see certain things in science, we understand really the significance of them. So there's two different things that are going to show up that are always disputed or maybe looked at and misspoken about by a lot of different people. The first of these are going to be scientific theories. Now, we are in a science classroom right now. We are not in a church. We're not in a mosque. We are not in anywhere that's going to suggest any sort of religious or philosophical beliefs outside of the world of science. With that in mind, if we talk about a scientific theory, oftentimes what people who are arguing against any particular theory, no matter what it is, they're going to argue that it's not a fact, it's a theory, or something along those lines. And it sounds completely reasonable when you hear it, and it's worded like that. However, when we look at scientific theories, there's two really important aspects that we need to make sure that are covered with it. First and foremost, at its most basic, when we try to distinguish between a scientific theory and a scientific law, there's an easy way to differentiate between them. A scientific theory is an explanation of the why, and I'm going to put that in quotations, or how a particular event occurs. Now, for theories, if there's a theory that doesn't jive with your own personal beliefs, which will inevitably happen at some point in your lives, maybe this year, maybe next, whenever it happens, it's an explanation of the why or how something happens. So evolution, people are going to bring in, we're not in a biology class, but people are going to bring in a whole lot of different beliefs around that idea, and there's going to be controversy that results from it. If I presented another theory, like the theory of gravity, is that one as controversial? No. Do you guys know who you attribute the theory of gravity to? So he was the first one to come up with the idea of gravity, and he actually discovered some of the laws of gravity. The theory of gravity that we adhere to right now is based on work done by Albert Einstein and his predecessors, and successors, sorry. So as we look at this, the most important thing, theory is the why or the how. That's all that it's telling us. It's an attempt to explain how or why something happens. Now, these are not just picked out of the air and just random. It's not like I can come in here and say, oh, I want people to believe this, so here's my theory. Like, that's not a scientific theory. That's just an opinion, and that doesn't really hold a lot of value in the world of science. For a scientific theory, even when it's called a theory, it relies on a ton, and we'll say on many. I'm going to underline it because that's super important. Theories are formed, and they rely on many observations and experiments. And I say or experiments because it depends on the situation. They rely on many, many, many observations or experiments by experts in the field. Okay, they don't just magically appear. They are based off of sound science experiments and observations that have been made. Never once have I made the claim that these will never be disproven. Theories might be disproven, and we hope that they are, because the second you disprove a theory, it shows that our knowledge is growing and we're correcting something that maybe we didn't fully understand. Okay, as opposed with the why or how, there's another scientific meaning that is much more powerful, but just slightly different. In contrast with a scientific theory, we also get the privilege of working with scientific law. Now, the theory of gravity will never become the law of gravity. You cannot transition from one to the other, because theories address the why or the how, and laws address something completely different. A scientific law, rather than trying to explain why or how something happens, all a law is going to do is explain what happens. For a particular event. Anybody notice that up above the sentence doesn't make sense? Did you notice it when I wrote it?
Yeah.
Call me out right away. Explanation of the why or how a particular Event. And you might have even wrote event because I said it like 10 times. I just never wrote it down myself. The change I just made will make it a different color because as I looked up, that was nonsense. Event. The word phenomenon also is a good one, but that's a longer word. Okay. Theory is the why or how something happens. The law is what happens. So, if we think about scientific laws, do you know any of them? So the law of inertia. Yeah, absolutely. We'll cover that in depth. A nice one that I think we can just all agree on whether we talk about inertia or not in that specific vocab. Does gravity happen?
Yes.
Are objects attracted in space?
No.
So are objects attracted to each other in space via gravity? Why are we going around the sun?
Gravity. Or gravitational
Gravitational
pull.
Okay, so we are attracted through gravity. Like we're objects in space, right? We're just on this big spaceship going around the sun. Like that's pretty cool. It happens. We see it happen. We use it every day when we use GPS and satellites and all those things. Like the fact that gravity happens, yep, it does. That's a law. It's called the law of universal gravitation. There's a fairly simple mathematical relationship if you know the mass of two objects and the distance between them about how strongly they're connected. Okay, however, anywhere in there, when I say gravity exists, am I giving you a reason to why it happens or how it happens? If I just say it exists, there's no explanation, right? I'm just saying this is what happens. It does happen, not giving you a why or a how. If I start saying that, wait a second, gravity is actually the result of heavy objects bending space and time itself, I'm not just saying what happens, they're attracted via gravity, but I'm trying to give you an explanation of why, which may or may not just go right over your head. That's not the point right now. Fundamentally different ideas around the same thought process. Okay, theories, how and why, laws, what. I'll say what if we want to stay consistent. Hate that the color's not consistent though, so I'm going to do that. Okay. We have finished our first section. Did we talk about homework in here? Okay. So I mentioned I have worksheets for you today. It won't happen every day. But for homework, we have a time limit. You have a life outside of the classroom. I have a life outside of the classroom. I'm going to give you a worksheet right now. You have like 2 or 3 minutes to get started, which legitimately you'll be able to finish the first problem easily, or at least quickly. Anybody ever gone home and tried to start working on a homework and it takes forever and you wind up crying on your bed because you're so stressed out and like you hate life and school and why are you even trying and like it's so stressful sometimes? Not with my stuff. I don't ever want it to be stressful. If I give you guys an assignment, let's just have a hard rule right here. 30 minutes outside of my classroom. If you get to the 30-minute mark and you're not done, okay, that's fine with me. Stop where you're at. If anything that I give you winds up taking longer than that, it means one of two things. Either I gave you too long of an assignment, or I didn't do the best job when I taught it, and we should probably go back and make sure that you understand well enough to do it in that time. Are you going to spend an hour and a half on my assignment? No, you shouldn't. You can. I would advise you not to. 30 minutes. If I give you something at some point and you're at the 30-minute mark, regardless of what time it is, shoot me an email, say, Holloway, I tried for 30 minutes, I couldn't get it. I will be there tomorrow. I'm here every morning. Come ask questions. I'm here at lunch every day, so if you don't finish your homework, this is right after lunch. You have the opportunity to come and finish it with my help if needed. Okay. No worries. On this one, this is a quick summary of the stuff that we talked about in this first section. Tomorrow at the start of class, we'll put on our math hats and we'll jump right into doing some what feels like real physics stuff. I never know, with the exception, I'll tell you tomorrow, I will collect this. If you lose the worksheet, you have access to another worksheet on Google Classroom. Moving forward, I never know if I'm going to collect it. I let the calculator or the flip of a coin determine whether or not I collect this and put it in the grade book. If you do an assignment and I don't collect it, does that mean you just wasted your time? No, it might feel like it, but if you're learning in the process of completing it, you're not wasting time at all. Awesome. You can work for a minute. If you want to start packing up, we are almost there. So I have no issue if you do that. Bring this back. This is due tomorrow at the start of class. If tonight you try it and you go, oh boy, I don't like this, I don't get it, come talk to me at lunch. You can bring lunch in here as long as you don't like spill everywhere.